Welcome to today's video where we delve into a fascinating problem regarding performance differences in Java 21 and Java 23. The problem at hand involves a CPU-bound code snippet that performs intensive calculations on double types, aiming to compare the execution times under different Java versions. The main focus is on single-threaded performance without using heap memory, showcasing intriguing results that raise questions about what changed in Java 23 to boost speed. Now, let's dive into the solution provided for this performance problem. The solution involves analyzing a simplified JMH benchmark code snippet that computes a mathematical operation in a loop. By profiling the code with the Professource profiler, we can observe the generated assembly code for JDK 21 and JDK 23. The key improvement in JDK 23 lies in the addition of extra vector instructions, which optimize the conversion of integers to doubles by breaking unnecessary dependencies. This enhancement, highlighted in JDK 831, 8562, and the associated PR, contributes to the significant performance boost observed in Java 23 compared to Java 21. Continuing with the solution exploration, let's zoom into the specific assembly code snippets from JDK 21 and JDK 23 to uncover the performance disparities. The assembly instructions showcase subtle but impactful differences, such as the introduction of vector instructions in JDK 23. These additional instructions play a crucial role in optimizing the conversion process, ultimately leading to faster execution times and improved overall performance. Transitioning to the next phase of our analysis, we further scrutinize the assembly code snippets from JDK 23 to grasp the nuances behind the performance improvements. By examining the intricate details of the assembly instructions, we gain insights into how the incorporation of vector instructions strategically enhances the efficiency of integer to double conversions. This meticulous optimization, highlighted in the code snippets, elucidates the underlying advancements that contribute to the remarkable speed enhancements in Java 23. To summarize our exploration of the Java performance puzzle, we've uncovered the crucial optimizations implemented in Java 23 that significantly boost the execution speed of CPU-bound computations. The strategic introduction of additional vector instructions in the assembly code plays a pivotal role in breaking unnecessary dependencies and optimizing critical operations, ultimately leading to a notable performance leap. With Java 23 showcasing superior speed and efficiency compared to its predecessor, these enhancements underscore the continuous evolution and refinement of Java technology. Thank you for watching, and don't forget to subscribe, like, and drop a witty comment below to join the discussion.